We'll start the session. So still we are doing Gauss divergence theorem, right? Only one problem we did in the last class. So in this class we are going to start with this problem. Verify divergence theorem for a vector function. Vector function f is equal to this much. So using Gauss theorem, we need to verify it. Okay. So first we'll do by triple integration or volume integration. And then we'll proceed for surface integral. And we have to check volume integral and surface integral will get the same value or not. Okay. So solution. Okay. So here f value he has given, just write it, f is equal to x square minus yz into I plus y square minus zx into j plus z square minus xy into k. Okay. Taken over a rectangular parallelepiped they have given. We'll think of this later. So here divergence f you need to find first. Divergence f is equal to how much? Dou by dou x of f1 plus dou by dou y of f2 plus dou by dou z of f3. Okay. So this one is equal to what is f1, f2, f3? I quotient is f1, j quotient is f2, next k quotient is f3. Okay. So dou f by dou x. So that means dou by dou x of x square minus yz plus dou by dou y of y square minus zx plus dou by dou z of z square minus xy. Okay. So this one is equal to, is what is differentiation of this? With respect to x, first one, it is 2x plus 2y, yes, plus 2z. So divergence f, we got it as this much. Okay. Now what we need to do? By Gauss divergence theorem, we need to find volume integral of this. Okay. So that means apply volume integral v divergence of dv is equal to volume integral divergence f value, we write it here. So 2 into x plus y plus z. Okay. So here I am starting with dz, dx, dy. Dy, dx. Okay. So this one is equal to, we need to write the limits. What are the limits for x, y and z? Here only they have given in the question. Taken over the rectangular parallelepiped where x ranging from 0 to a, y ranging from 0 to b, z ranging from 0 to c. So last integral is x. So that means 0 to a, 0 to b, here 0 to c. Okay. So 2 into integral 0 to a, integral 0 to b. So with respect to z you need to integrate. So that means xz plus yz plus z square by 2 dy dx having the limits 0 to c. Okay. So this one is equal to 2 into integral 0 to a, integral 0 to b. Okay. So apply the limits. How much you'll get? Cx plus cy plus c square by 2. Okay. So if you apply 0 limit, so all terms will become 0. So dy dx will be there. Okay. So this one is equal to, take this c outside, or you can keep this here itself. Integral 0 to a. Okay. Now second integral is y. So integrate with respect to y. How much you'll get? Cx into y plus first integrate with respect to y, we'll see. Cxy plus cy square by 2 plus c square by 2 into y. Limits are from 0 to b dx. So this one is equal to 2 into integral 0 to a. Okay, apply the limits. How much you'll get? dcx plus cb square by 2 plus c square by 2 into b dx. Now at last we need to integrate with respect to x. So 2 into, how much you'll get if you integrate with respect to x? bc x square by 2 plus cb square by 2 into x plus c square b by 2 into x. Limits are from 0 to a. Okay. So this one is equal to 2 into, so how much? bc a square plus here by 2. Next, a b square c by 2 plus a b c square by 2. Okay. So this one is equal to, take LCM, how much you'll get? 2 by 2, 1 by 2 I have taken common. A square bc, okay, plus a b square c plus a b c square. So 2 to get cancelled, this much will be the answer. Okay, so the value of triple integral divergence f dv over a volume integral v is equal to, we got a square bc plus a b square c plus a b c square. Okay. So now we need to find RHS part or LHS part. What is the LHS part? Double integral over a surface S, curl F, So what is Gauss divergence theorem? F dot n cap ds. Okay. So in the previous integral in the Stokes theorem, we have taken dx, dy dzi plus dy dzj, next dx dyk. So instead of that, we can select this one directly by observing the diagram. We'll do this in it here. Okay. So first we need to write the given parallelopiped. So we have to write the diagram for it. Okay. So we'll construct the diagram. Okay. Here I am drawing one rectangle. For surface integral it will be useful. For volume integral only limits is fine. Okay. So I am drawing a rectangular box in 3D mode. Okay. So if you observe these middle three lines, these three lines I am taking it as x-axis, y-axis and z-axis. So one minute. So you have to draw the diagram like this. Just connect the vertices of both the rectangles. Okay. Now I am taking this line as my x-axis and this line as my y-axis and this line, this line I am taking it as y-axis, this line I am taking it as z-axis and this line I am taking it as x-axis. Okay. So this middle one you have to take it as origin O. Okay. Next, here on x-axis, I am taking the point as A. On y-axis, I am taking the point as B. On z-axis, I am taking the point as C. Okay. Next, D here. E, F, and this middle point, I am taking it as P. Okay. Now, we need to check what is the unit vectors along the axes. Okay, so unit vector along this axis is J, because along y-axis it is J, along x-axis it is I, along z-axis it is K. These are the unit vectors along these vectors or this axis. I cap, J cap, K cap. Okay. So this is the main important, these unit vectors play a very important role in finding the integration of surface. Okay. Now total surfaces are how many here?
6.
So total 6 surfaces. So for all 6 surfaces you have to find the integration. And then if you club it, then you'll get the answer. Okay. So that is the difficulty for finding surface integral. Okay, so area of the surface can be found by portion, and you are going to club like line integral we have done, right? In the same way, surface integral also for 3D object we will be do like this. Okay, now first we will observe the surface S1. Okay, S1 I am taking it as OADB. So what is OADB? Check once. OADB. So that means this one. This part. Okay. So that means bottom of the box. Next. S2. I am taking it as OCEA. So what is OCEA? Check once. OCEA. So that means this side of the box. That means left side of the box. Next, S3. S3 I am taking it as OBFC. Okay. So where is OBFC? Check once. OBFC. So that means this part. Okay. So this part of the box. Next, S4. Okay. On S4, CEPF. Okay. So what is CEPF? Check once. This is top side of the box. Okay. So this one. So this part. Okay. So next S5. You need to identify each and every face of the box. Okay. Next BF PD. So BFPD. So where is BFPD? So that means this side of the box. Okay. Next to S6. S6 is nothing but ADPE. So ADPE. So ADPE. That means your side. Box face on your side. This side. Okay. So after identifying each and every faces, you need to perform integration along these surfaces. Okay. And here they have given n cap, right? Okay. Here this n cap is nothing but outward normal to the surface. Okay. So that means perpendicular to the surface. The vector perpendicular to the surface is called outward normal. Okay. So let us see what and all those outward normal for these surfaces. So I will start integration by side. Okay. Along first side OA DB. Okay. So I have to find integral f dot n cap ds, right? So surface integral along OA DB. Okay. F dot n cap ds is equal to, so double integral f. What is f? So check it. X square minus yz I plus y square minus xz j plus z square minus xy k. Okay. So dot n cap is there. So to identify n cap, what you need to do is observe this side OADB. So OADB in which plane? XY plane or YZ plane or ZX plane? Down part of the box. So you need to identify which plane it is located. OADB. So which
XY
axis
plane.
it is? XY plane. So in XY plane, what is the perpendicular vector to XY plane?
Minus k.
So you'll get k, right? So but k is moving in away from the surface. So it is moving away from the surface. So I have to take minus k here. So direction also included here. So if your unit vector is towards your surface, then you have to take plus k. Okay. Then your surface is outward from the vector. So that is minus k. So this vector is moving outward to the surface. So that's why I have to take minus k. Okay. So you'll get dot minus k. Since it is of xy plane, so I have to write dx dy. Okay. So if you do the dot product with this one, how much you'll get? Dot product with this. Only k function will be there. So that means minus z square minus xy. So k dot k will be 0 dx dy. Okay. But on xy plane, which value will be 0? Z value will be 0. Okay. So we have to keep it. So minus of minus will get plus. Okay. Xy dx dy. So now you need to write the limits for dx and dy. So what are the limits for dx and dy? In the question itself they have given 0 to a and 0 to b. So x limits are from 0 to a and y limits are from 0 to b. Okay. So this one is equal to, just you can perform the integration now. Integral 0 to a. So if you integrate with respect to y, sorry, with respect to x, sorry, here outer integral is y. So I have to write b outside. Here it is b. Integrate with respect to x, you'll keep y aside, x square by 2. Limits are from 0 to a dy is equal to integral 0 to b y into a square by 2 dy. So this one is equal to a square by 2 into integration with respect to y, you'll get y square by 2. Limits are from 0 to b. So this one is equal to a square by 2 into b square by 2 will get. Okay. So overall value is a square b square by 4. So surface integral along OA dB will be f dot n cap ds. Value is a square b square by 4. Okay, in the same way you have to find all the 6 surfaces. So let us do one by one. Double integral f dot n cap ds. Okay, so here the surface, which surface? S2 OCEA. Okay, is equal to double integral. Check OCEA here. OCEA. It is in which quadrant or which plane? OC. That means this side. Which plane it is? OCEA. This part is which quadrant? Which axis is there? This side. XZ. So you have to write XZ. So that means dx dz you will write. Okay. So when it is dx dz, inner integral limits are 0 to a, 0 to c. Okay. Now what is the n cap value? N cap value is perpendicular to the surface. So what is the perpendicular to yz plane? Sorry, xz plane. Y-axis, right? Y-axis is perpendicular to xz plane. On xz plane, what is the unit vector? J vector. And the j vector is moving away from the origin, right? So you have to take minus j here. So what is the j term in f? That term only you take and do the dot product. So you'll get minus of y square minus xz into, or you can write that much only. Otherwise, y square minus xz into j dot minus j. So remaining terms anyhow it will be 0. So I don't want to write here. 0 to c, integral 0 to a. If you make a dot product, you'll get minus. Okay, since n cap equal to minus j, and here y value will be 0. On xz plane, y value will be 0. So I substitute these two values in this equation. So what happens? you'll get xz dx dz will get. So apply integration, integral 0 to c, you'll get with respect to x, if you do x into, sorry, z into x square by 2, 0 to a dz is equal to, so this will be a square by 2 integral z dz 0 to c. So this one is equal to a square by 2 into here c square by 2. Okay. Here z square by 2 integration value 0 to c.
Excuse me, sir.
S a square by 2 c square by 2. Yes, pa.
Sir,
Hmm.
sir, there y minus j, sir, unit vector. It is plus, no, sir. Unit vector.
No, here that is what I said. This unit vector is moving away from the surface. Okay, when that unit vector is towards that surface, then you have to take plus j. Okay, so the surface is this side. Okay, here, but unit vector is moving opposite side, right? So you have to take minus j there. Clear?
Yes, sir.
Whenever the unit vector is towards the surface, then you have to take plus j. When the unit vector is away from the surface, then you have to take minus j. Okay. So you will come to know in the coming sections we will take plus j, minus plus I and plus k also. Okay. So next value you need to find surface integral f dot nk n cap ds. Okay. Over the surface S3. S3 is here OBFC. Okay. So this one is equal to double integral. Here we have to write OBFC, you have to observe. You observe OBFC, where it is OBFC. So that means this side. Okay. So what is this plane actually?
YZ.
So I'll get YZ plane. So what is the perpendicular line to the, what is the perpendicular axis to it?
I.
I, right? So that means x-axis. So here, what is the n cap value is nothing but minus I. Okay. So we'll do the dot product with I term. So what is I term? This x square minus yz into I. Okay. So here this quadrant is yz. So we'll get dy dz here. So z limits are from 0 to c, y limits are from 0 to b. So this one is equal to, on this x value will be 0 on yz plane. So take x equal to 0. So double integral 0 to c, 0 to b. Okay. So minus of minus will get plus, I dot I value will be 1, you will get yz dy dz. So this one is equal to integral 0 to c z into y square by 2, limits are from 0 to b, dz is equal to integral 0 to c, you will get b square by 2 into z dz. So this one is equal to b square by 2, you will get z square by 2. Okay. So this one is equal to, limits are from 0 to c here, b square by 2 into c square by 2 will get. So the answer is b square c square by 2. So this is the integral for OBFC f dot n cap ds. Okay. Now double integral with surface S4 CEPF. CEPF, sorry, F dot n cap ds is equal to along CEPF. You have to observe the diagram. CEPF. So it is related to all the three axes. Okay, that means it is in the space. Okay, if even though if it is in the space, we have a constant value. Okay, but the region will come under where? Which axis?
X and Y.
X and Y axis. That surface will come under XY axis, but some height in the Z axis. Okay, so what we need to do is here, this is dx, dy. Here the value is unit vector. Unit vector is k, but this time this k vector is towards the surface. So you have to take plus k there. Okay. So here n cap value is plus k because the unit vector is towards the surface. So you have to take plus k. And what about x value? Sorry. This is in which plane will get dx dy. Z value will be how much? How much height it is? Okay, this height is nothing but this value will be 0 comma c. 0 comma 0 comma c it is. Okay, c distance. So z is equal to c will substitute. Okay, so here f dot nk value. So will be how much? I quotient. I quotient is x square minus yz. X square minus yz into I. Sorry. K quotient you have to take. Z square minus xy into k dot k. So limits are from outer integral is for 0 to b, inner integral is for 0 to b. Sorry, 0 to a. 0 to b.
dx dy plane.
Huh?
How is it in dx dy plane?
Dx dy means in which surface it is. In which this surface is there, right? This surface is coming on x and y axis.
Not z and y.
Huh?
CEPF, no sir. Upper surface.
CEPF.
Yeah.
This one.
So
This will come under here only, na? This plane only, XY plane only. XY plane.
CEPF.
Yes?
CEPF is upper part, no sir.
Upper part. That is what.
There, it's not zy plane.
Huh?
It's not zy plane.
No, when OADB is in XY plane, this also will come under XY plane only, na? This is the bottom of the box. This surface is bottom of the box. This surface is top of the box. When bottom of the box is XY plane, top of the box is also XY plane only. Correct? Correct, na? But only the space has been between these two. So how much space is happened means Z is equal to C. That much height we have mentioned here. Previously we have taken Z is equal to 0. Okay, but now we have taken Z is equal to C. That means the side is upper, they are having some height. So that height is nothing but Z equal to C here. Okay. So integral 0 to a c square minus xy, k dot k value will be 1. So dx dy. Now apply integration for this. So integral 0 to b. So c square x minus x square by 2 y, having the limits from 0 to a dy. So this one is equal to integral 0 to b. If you apply the limits, so I'll get c square a minus how much it will be? A square by 2 into y dy. Okay. Now again apply integration with respect to y. So c square a integration 1 dy is y minus here a square by 2 into y square by 2, having the limits 0 to b. So if you apply these limits, how much you'll get? C square a b minus a square b square by 2. Sorry, a square b square by 4. Okay. Next surface is surface integral along EF PD. Okay. BF PD. F dot n cap ds. So here what is n cap and what is the plane? So BF PD. So what is BF PD? Check once. BF PD. So that means this side of the box. So what is the axis of that? What is the plane of that BF PD? Plane.
XZ.
XZ plane. So in XZ plane, the unit vector is towards that surface, right? This unit vector is towards that surface. So you have to take a plus j there. So n cap is equal to plus j, and this will be 0. Y will be 0. Okay. So double integral xz means dx dz will come. Okay. So here j will be there. Dot j quotient you have to write. So j quotient is y square minus xz into j. Okay. So limits are from 0 to a, 0 to c here. So this one is equal to integral 0 to c. So if you make a dot product and if you substitute y value. So but here y value have some height. Okay. So what is that height? 0 to this b. So y equal to b will get. Okay. So integral 0 to a b square minus xz dx dz. Okay. So this one is equal to integral 0 to c b square x minus x square by 2 z, having the limits from 0 to a dz. Okay. So apply the limits. How much will get? Integral 0 to c b square a minus a square by 2 z. Okay. dz. Okay. So this one is equal to apply integration with respect to z. So I'll get b square az minus a square by 2 z square by 2, having the limits from 0 to c. So b square ac minus a square c square by 4. So the answer is b square ac minus a square c square by 4. Okay. So double integral df pd value is f dot nk ds. Okay. Now last surface, that is double integral adp. Okay, adpe f dot nk n cap ds is equal to double integral adp. Check this. adpe. So that means this side. That means towards your curve. Your side, towards you. So which surface it is? Which plane it is?
YZ.
This is nothing but YZ plane. Okay. So we'll get dy dz here, and n cap will be I. Okay. Because I vector, that means unit vector I, is towards the surface. Okay. That's why you have taken plus I. Okay. Next, x value will be how much? X value will be a here. Okay. So taking n cap equal to I, x equal to a, you have to write here I term. Okay. So what is I term here? X square minus yz. Into I dot I. So limits are from 0 to b here, 0 to c here. So is equal to integral 0 to c. Substitute this, we'll get 0 to b a square minus yz dy dz. So this one is equal to integral 0 to c. Apply the integration with respect to y, you'll get a square y minus y square by 2 z. Okay, dz. So this one is equal to integral 0 to c. Limits are from 0 to b here. So a square b minus b square by 2z dz. So this is nothing but a square b. Apply the integration with respect to z. A square bz minus b square by 2 into z square by 2. Limits are from 0 to c. So a square bc minus b square c square by 4 will get. Okay. So surface integral over ADPE surface is f dot n cap ds. Okay. So therefore total surface area along the surface S f dot n cap ds is equal to, you have to add all the surfaces. So add all the surfaces. First surface you got it as a square b square by 4. A square b square by 4. Next surface a square c square by 4. A square c square by 4 plus b square c square by 4. Next plus ABC square minus AB square by 4. Next plus AB square C minus A square C square by 4. plus ABC square minus, sorry, A square BC minus B square C square by 4. Okay, so all the terms will get cancelled. So A square B square, here A square C square, B square C square get cancelled. So what will remain? ABC square plus AB square C plus A square BC. So surface integral f dot n cap ds. So take it as equation 3. Take this as equation 2. Okay. So from equation 2 and 3, okay. So surface integral S f dot n cap ds is equal to triple integral v divergence f dv. Okay, which implies Gauss divergence theorem is verified.